Come to another topic. This topic is execution, timed automata execution, or even for state machine execution. So what the execution? The execution is the behavior of the system. We study the behavior of the system, how the system is run. So the execution is the sequence of the transition from one state to another state. The sequence in the transition state, and this one is it can be sequence of finite or state or sequence of transition, and this one can be finite or infinite state. So here I have an example. So we see here an example. Here we have one state, and here's some execution of these when state automata. For example, the first execution, we can see the user run the user move from S1 to S3 to S2 to S3. So this is the first execution, S1, S2, S3. So here the input was 0 and then the input 1. So from here we have only input 1. But we can have another execution, for example, S1 and then back to S1, or stay in S1 and then S2 and then back to S1 and then move to S3. So here another execution. So here execution, infinite execution. So we can see here S1, S2, and then S1, and then S2, and then back to S1, and then just staying in these two state. So here infinite execution. See our example, the coffee machine example. So the execution or the run of this machine, we can say we have here start and then the cup, get the cup, and then coffee. So without goes to adding any sugar. So the first execution, for example, without sugar. So just start moving to the second sugar, adding sugar, but we don't add sugar. That means not goes to adding sugar. We just go to get the cup and then the coffee. But we can see here another execution, but with sugar. So we start and then we move to this state, adding sugar. In this state, so we press the execution of coffee machine, and then can be as we add another sugar first, and then if you want a coffee deliver no sugar, the coffee, so and then back to the start initial state. So here the execution then of the we will move here, and then here both x and y will reset to how about 0. The execution of once you reach to timing automata blue states which adding sugar, so don't press adding sugar, you just stay there, stay in the blue state until the guard allow you to move from this state. That means we should to stay there until the time is pass 5 unit times, and then you press or and then the coffee machine will deliver the coffee to the user, and the time still 5. Here we stay there 3, we stay here a 3 unit time because we cannot pass this transition until so if y equal to 8, so a coffee once y equal to 8, that means 5. So we'll start with the green button. We can the green locations. The once you press state start, you will move from the green location to the blue location. In the blue location here, in the blue location, you can wait as much as you can, but should be less than 5 unit of time, and more 1 unit of time, because here we have a conditions in the location, also we have a condition in this transition. So the transition here should be more than 1 or equal 1, and the location it's less than 5. Suppose we stay here 1.5. So we back to blue again, we back to blue again. So x is reset because we have here x equal to 0, but y it's continue 1.5. So if we press again sugar one more times, so the same as much as we want, but should be more than 1 and less than 5. Suppose we stay 2.7. So and then we reset the x in the transition, we reset the x in the transition, and then we should to move from the location blue to y. We can move if y equal to 5. So the y here equal to 5, that means the y is wait until 4.2 is equal to 5. So we wait 0.8, because from 4.2 to 5 it's zero point 0.8. The x from 0 will become 0.5, 0.8, and 4.2 plus a plus zero point 0.5, 0.8 will become 5. So once y equal to 5, so we can pass this transition to delivering the coffee, and then in the delivering coffee you just need to wait another more 3 unit of time, because y should be equal to 8. Here y is equal to 5, so we just wait another 3 time units to pass this transition, so and then we can get our coffee. Here we have a very simple example. The example have it's a switch, to switch lighting, to switch whatever, just a switch with two state. The first state is on, the second state is off, and we have here a condition that's the time we can return. I mean, if you are in the location on, so we can return to off only if there is only if 2 unit of time already passed and not more than 3 unit of times. It's very simple exercise. You can do it and submit it by next week. So all what you have to do is to model this system using timed automata, and then to study the execution of your timed automata.